So this is the question asked in winter 18 exam. This is for 6 marks question. Question is what? Refer the diagram shown in figure 4. This is the figure 4. What should be logic level at D input to make first LED on, second LED off, and justify your answer. So students, first of all we examine the figure. So here this is a D flip-flop. This is SR flip-flop. This gate, you remember, this is a AND gate. This is the symbol of LED. Okay. One more thing, here is a NOT gate. Now, what is said? LED is on. First condition is what? LED on. Before proceeding, let us remind some certain things. This LED will be on when current passes through this. Okay? When there is no current, LED will be off. Second, this is the AND gate. Output of AND gate is high when both the inputs are high. Isn't it? So, both of these will be high. This by default it is given as high or plus 5 volts. So, it is 1. So, if this is 1, output will be high. This is SR flip-flop. SR flip-flop. This is also called as a set reset flip-flop. Now, its output, it is having 2 input and 2 output. And you can see QA and QA complement. That means the whatever is the QA will be the complement. So both the input outputs are complement of each other. So what is SR flip-flop? Output of it. So we consider this QA. Do not consider this QA complement because it is connected here. So output, this QA will be 1 when S input is high. And that condition is called as a set condition. Set. When S is given 1, QA will be 1. Isn't it? Now here by default, here is a NOT gate. So if it is 1, then this will be 0. Okay. So this is the default condition that S is given as 1. Now this will be 1. This is one more flip-flop, that is a D flip-flop, or it is called as a data flip-flop. D flip-flop. It is having only 1 input and 2 output, again Q and Q complement, which are complementary to each other. The speciality of D flip-flop is what? Whatever is the input given to D, it appears at output. So if you give here 1, output will be 1. If you give here 0, output will be 0, or Q output will be 0. So see, first condition, when LED is on. LED on. So what is the condition for LED to be on? This LED to be on. So first condition, that AND gate inputs should be high. So this is already high. This should be high. So QA will be high. QA will be high when S will be 1. Isn't it? So this is a set condition. The flip-flop will be set. So if S is equal to 1, this QA will be 1. And for this S to be 1, D flip-flop, the input D, if it is 1, then its output Q is 1, and then S is equal to 1. So are you getting? What is the condition for LED to be on? If it is on, this input QA, which is the input of the AND gate, should be 1, that is QA should be 1. For QA to be 1, S should be 1. For S should be 1, Q should be 1. For Q should be 1, D input should be 1. So this is the condition. This is our justification for LED to be on. Now second is what? For this much explanation, 3 marks are given for solution. Okay. Now what is LED off? Second is LED off. Now you might understand when this will be off, this is off, when this will be 0, because this is already 1. When this will be 0, according to SR flip-flop, if R input is given 1, then its QA will be 0. Means this input will be 0, or this is called as a reset condition. So we have to reset the flip-flop, and to reset the flip-flop, R should be 1. Here is a NOT gate. So what S will be? If S is given 0, then R will be automatically 1, and this flip-flop is into reset condition. Now if this S should be 0, Q should be 0, isn't it? And this is the D flip flop. When this Q will be 0? When the data input is 0. So see here, in order to LED to be off, if D input is 0, its Q output is 0, which is the input, S input. If it is 0, the QA, that is a reset condition, it will be 0. If it is 0, this diode is, its output is 0. If its output is 0, this LED will not glow. LED off. Okay, you understand? Thank you.